We're live. All right, Precalculus. Today's date is Monday, January 4th. Let's come here. January 4th, 2021, our brand new year. 2020 was not the best year. The bar was nice and low, so it should be easy to make this year a better year, right, guys? Our objective today, who wants to read that?
Dibs.
Sorry, it looks like Beverly had her hand up first.
You can read it.
Okay, go for it, Chewy.
She can have it.
Evaluate composite functions and equations, tables, and graphs.
There it is. So this word composite functions, what's even going on here? So let me talk about that first. So vocab, function composition. Whenever you compose one function with another, it just means you're applying a function to the other function, to the output of another function. So we've been dealing with functions for a long time, like especially in Algebra 1, right? We had the function 2x, which was the doubling function. You put in a number and then the output is doubled. Well, now what if I have two different functions? I have maybe the doubling function and then the tripling function. I run it through the doubling function, and then as soon as I'm done with it, I run it through the tripling function. That's all it means to have function composition. Run it through one function, then run it through the next function. So how do you write that? These are the two different ways of writing the notation. So I'll write this too. These two notations, these are the same thing. And what is happening here? First, I can do a picture representation. First, you have some input. I can say X is the input. So maybe I chose 2. 2 is the thing I'm going to be feeding into these functions. Fx is going to go into first the F, which maybe seems weird to you. Shouldn't you do G because G's on the left? We read left to right. No, in mathematics, when we do function notation, we actually go from right to left. So X first is being plugged into F, and then after that, it's going into G. So you go from right to left instead of going the other direction. It's backwards reading. So X is first going to be plugged into your f of X function. And then after you get the output of f of X, this output goes into G of X. So this is the way that you want to be thinking of things. First go into F, then go into G. And then this is the same thing. X goes into F and it goes into G. This notation, by the way, this circle is not filled in. This is kind of like an open circle. This is saying G composed with the function F of X.
Wait, I have a question.
Yes.
So when it's G of X, is that X what F times X is, or is that just the X?
So I'm slightly confused.
I feel like I said that in a confusing way. Like, so the f of X is that input you get from taking f of X, then being the input into G, or is it like two separate things? You have f of X and then you have G of X.
I see. Okay. Yeah. So they're not separate things. You don't multiply them. I think that's probably the most common mistake. You don't multiply the input into G of X multiplied by f of X. You first take your number, plug it into f of X. Then you get a number out. You take that same number and now use that as the input to go into G of X.
Oh, I see. Okay, that makes sense. Thank you.
Yeah, you're welcome. And then it will be made clear too with examples if anyone else is still confused too. So here's an example. F of X is this function that squares it, and then you subtract 11, and then G of X is just the square root function. All right, so let's try this out. I want to evaluate G of F of 6. This is a composition of functions because one function is inside of the other function. So what do I do first? Do I do G of 6 or do F of 6? Do I go into this first function or the second function first? And I will hopefully have one of you have a quiet raised hand to tell me which function do I plug 6 into? Do I go 6 into this first X or 6 into that second X? Which one goes first? Quiet raised hand. Come on, you got this. Does 6 go in that first X or does 6 go in that second X? Which function am I starting with, F or am I starting with G?
F?
F, yeah, you're right. And it should have been a quiet raised hand, but we'll get used to that again. Yeah, so it goes into F because F is the first thing, the most inside piece of this. So 6, I'm trying to find F of 6. I'm trying to plug in 6 into this equation. So I'm saying, okay, this is really saying G of, then what is F of 6? F of 6 means I'm plugging 6 into this x squared minus 11. So I'm going to say 6 quantity squared minus 11. F of 6 is that 6 squared minus 11. You can say, okay, well, 6 squared minus 11, I haven't done G yet. So 6 squared is 36. So I can say this is really, let me back up so I have enough room. G of 36 minus 11, which means this is really G of 36 minus 11 is 25, which means I now need to plug 25 into G. So then we do that. I plug 25 into this G function. This G function says, whatever your input is, square root that input. Our input is 25, the square root of 25 is 5. And we're done. So G of F of 6 is 5. Let's try another one, unless there are questions. Okay, so this 25. Is 25 going to be plugged first into the first X or the second X? Someone aside from Ellery who did the last one.
G.
Yeah, Caroline?
The second one.
Yeah, why?
Because we're starting with G now.
Yeah, G is the most inside one. We're starting with G. So what is that, Caroline? When I plug 25 in, I get square root of 25, Caroline, is
5.
5. Exactly, yeah. So Caroline plugged in 25 into the second function because it was asking to be plugged into G. And we did that, it's 5. Then we plug in 5 into the next one. I need another volunteer, just try to get more people in here. When I plug 5 into F now, this is F. F is x squared minus 11. What is that going to be? You can just read it out. Just help me plug it in. Yeah, Beverly?
It's going to be 5 squared minus 11, which
Exactly.
is 25, which is 14.
14. There it is. Nice. We can box our answers. So hopefully everyone is starting to get more comfortable with the flow of this. You do the inside and then the outside. I'm going to switch up the notation on you a little bit, just to make sure you really know what you're doing. I'm going to give you 2 brand new functions. I'm going to call this first function A, and that A is t plus 4 over t. My second function, I'm going to call that B. B is 2t. It's a doubling function. Okay, slightly different notation. No question? No, okay. I'm going to do A composed with B, and then the input here is 1. So this 1, which function does this go to first? Another quiet raised hand, please. Does 1 go into A or does it go into B? It's one or the other. You got a 50-50 shot.
B.
Is that Emily? Yeah,
Yeah.
it is B. But if you could raise your hand next time, I'd really appreciate it. It does go into B. So what happens when you do that? I now have A of, when you plug in, this is really A of B of 1. I'm plugging into B first. So A of plugging into B is 2 times 1, which is just 2. Okay, so Emily plugged it into B first, and then we plug it into A. Again, we plugged into B first because you always go from the right to the left, and then to the left, to the left, to the left. So A of 2, I plug in 2. Can someone else help me do this math? When I plug in 2 to both of those t's, what do I get? Leo, you want to do it for us?
No, I'm lost.
Okay, what are you lost on?
Well, kind of the whole thing. So, for example, 1, like, you go off the f, so it's like f of x equals x squared minus 11, that thing.
Yep.
So you multiply that with the 6, with the g, f, and 6.
So whenever you see f of 6, this just means plug 6 into the function f. So this is the function f. Wherever you see any variable, replace that variable with this input 6.
So you just replace the x with 6?
Yeah, exactly. So that's what we did right here. So you can see inside here, it used to be x squared minus 11. Now it's 6 squared minus 11.
So what would you do with the bottom one, g of x?
Yeah, so once we, like this one right here.
Mm-hmm.
So now that we boiled down 6 squared minus 11, we know, okay, 6 squared minus 11 is 25. This is saying everywhere in G that you have an x, for this function right here, everywhere that there's an x, plug in 25 in the place of x.
Yeah.
And then that's the square root of 25.
Okay.
And so, Leo, if we come down here, if we're looking at the function a, this actually has 2 variables, so it is a little bit tricky, but both of these variables are going to be swapped out. They're going to be substituted for 2. This is saying plug 2 in for the function a. This is the function a. Everywhere that you see a variable, change that into a 2 in this case.
What about the 2t? Is that still 2 to the power of 2?
That's this b function, so you don't have to worry about that. We already, Emily used up the b function by plugging in 1 into it and got out a 2.
Well, then it would just be 2 plus 4 over 2.
Exactly, yeah. So this is now 2 plus 4 over 2, and that's equal to
6 over 2.
Yep, and
3.
3. Nice. Yeah, so when we plug in 1 into this composition of a and b, we get 3. Again, 1 got plugged into b. 2 times 1 is 2. And then we use that 2 and then plug that into all of the variables up here, and we got 3. Nice. Let's try it again. And I have no idea what's going on with my letters. It should be a letter A. Let's change that up. That should be letter A. Did I do that up here too? No. Now it's going to be the reverse. Notice this was A composed with B. Now this is going to be B composed with A. So first, 4 is not going to go into B. It's going to go into A. Who can do that for us? Yeah, Beverly, go for it.
So it's going to be 4 plus 4 over 4.
Yep.
And which is going to be 8 over 4, which is 2.
Exactly, yeah. So it's going to be B of 2. Yep, so when we plugged in 4 into A, we got out a 2. Now that we get out a 2, this 2 is going to be plugged back in to the next function, our B function. And Chewy, what is that going to be?
Hold up. Let's see. What was the question again? Can you ask it one more time?
So Beverly told us that when you plug in 4 into A, you get a 2. Now we're going to plug 2 into B. And here's your B function right up here.
So how do you get a 2 from plugging in the 4?
Yeah, so a good question. And we'll come back to you, Chewy, in a sec.
Mhm.
So when you plug in 4 into this A function, that means everywhere that there's a T, that's swapped out to a 4. So I wrote 4 plus 4 over 4. And we did the math kind of in our heads, but 4 plus 4 is 8. 8 divided by 4 is 2. All right, and then back to you, Chewy. So when I plug 2 into B, what is my output?
Honestly, I don't know. Hold on. I thought I knew, but
Okay, so our function B is this one. It's
would it be
2t.
just equal 2t again? But what would the t be?
Yeah, what is the t? The t is whatever the input is. T
Oh.
is the input, so it's 2 times 2.
Oh, okay.
We get 4. Nice. So again, the notation isn't super important. It is, especially if you're going to be taking another math class after this. This is called function notation. I know it can be confusing, but the basic idea is you're taking a number, plug it into a function, you get a number from that, the output of that function. Use that output and put it back in as an input to the next function. Just plug in a number, get out a number. Plug in a number again into the next function, get out your final answer. And you could technically have a composition of multiple functions, more than 2. You could have like 3 or 4 or 5, like 20, whatever. That's just a composition of multiple functions. All right, so on this first page, can you guys give me a fist of 5 on examples 1 and 2? How well are you following? Getting 4s, 5s, 3.5s, 5s. Oh, chat just popped up. Very specific, 3.9 and 3. Okay. So I see 3 from Oscar. Thank you. Let's try to do something slightly different. So this was the algebra. There's going to be 2 assignments that you have tonight. The first assignment looks exactly like example 1 and 2. The second assignment is a mix of example 3 and 4. So tables and graphs. So let's zoom back in here to example number 3. So example number 3, you can see that I have a table here. Notice that all of my inputs are X. So I have an input of -1, I have an input of 1, I have an input of 3, and an input of 5. With each of those inputs, I have a corresponding output. If I plug in -1, I get out a 4 for the W function. Similarly, the P function, if I input a 0, I get out a 3. So you can see input and output. They all have some input, and the output is depending on if you're W or if you're P. Okay, so let's look at A. A is saying, hey, I'm plugging in 2 into this composition of W and P. What do we do? Well, let me ask the class the question, like, 2 is going to be plugged into P or W first? Which one goes first? And with a quiet raised hand, someone will tell me. Quiet raised hand. 2, does it go into P or W first? Beverly?
P.
Exactly, yeah. So I'm looking not at this first graph, I'm looking at the second graph. I'm plugging into P first, it's the most inside, or it's the farthest one to the right. I get another way of thinking of it. So I'm plugging in 2, okay? If 2 is the input, which of these 4 values has 2 as the input? And better yet, what's the output when I plug in 2? Who can tell me? Anyone aside from Beverly? When I plug in 2, what is my output? It's one of those 4 values that you're going to be using.
5.
It is indeed 5. Yeah, thank you, Jaden. But if I could get a hand next time, I'd really appreciate it. Yeah, so
Sure.
Jaden is clearly seeing that the input is all up here and we have an input of 2. So I'm looking at this 2 right here. That 2 has an output of 5. So I come back over here and say, okay, well, I know what P of 2 is. P of 2 is 5. So I can reduce that and say this is now W of 5. Okay, well, that means I'm talking about the function W now. I'm coming up here to our first table. This is our W table. And I'm saying the input is 5. If my input is 5, what is my output for that first table? With a quiet raised hand. Yeah, Caroline?
6.
6, yeah. The input was 5 and the output is 6. So the answer down here, oops, that was a terrible 6. Let me make a better one, is 6. I want everyone to try this next one on your own. I'll give you guys about 30 seconds. I have the composition of P and W. If I plug in 1 into that function, what do I get out? What did you guys get? Does anyone have an answer? Yeah, Beverly?
Ooh, would it be 4?
How'd you get that?
So I did the W first, and I like got -2 out of it,
Okay,
and then I did to the P, and then I got in 4.
there it is. Yeah, this is 4. Again, you don't even have to write all of my fancy notation. You just say, okay, 1 starts in W. So I come up here to the W table, and I find the input, comes to -2. -2 is now the input. Find that -2, and then it goes to 4. Let's do a PISA 5 on tables. Composition of function with tables. 5, 5, 4, 4, 5. No one said anything in the chat. Okay, but those are high numbers. Let's move on to the last one, and in my opinion, the hardest one. Example 4. So example 4, I'm just giving you a graph. And this graph has 2 functions because I need 2 functions to have a composition. What does it mean to be an input or an output? And this is something I want to write down for our notes. The input, I can't write input. This is the X coordinate. And then the output is the Y coordinate. And this might seem simple, like I've seen this over and over, Mr. Sindel. I know the output is Y, but it really means something when you're doing a composition of functions. And then maybe if you don't like the output being Y, you can think of the output as the height. I know that sometimes helps me. So let's think about this. The input, the X coordinate, is originally -3. What function is that going to first? Someone new. Well, someone that hasn't participated very much. I don't know. Emily, -3, is that going to go into F or G first?
F.
Exactly. Okay, so let's mark this on our graph. At -3, I'm going to try to find where that intersects F. And I see, okay, well, F is the blue function. It looks like it intersects right about there. Emily, what is the height that F returns to it? What is the output of F of -3?
-3.
So -3 is the input, and then the output is somewhere on this y-axis.
2.
2, exactly. So we can now say this reduces down into just g of 2. The height of 2, the y coordinate of 2 is the output of f. And we're going to plug that output as the input to g. So then we kind of ignore everything that we just did. And I say, okay, now I'm going to go to the x coordinate 2. The x coordinate 2. X coordinate 2 is right here. And that lines up with the g function at what height? Someone else, tell me. Now that the x is 2, that used to be the height, the x coordinate is 2, what height or what y coordinate, what output do I get from the g function, the red line? Caroline?
-3.
Not quite. So again, this red line that I've just drawn right here, maybe I can do a different color. This green line intersects with this red line at what y coordinate? Right here.
Is it 1?
It is indeed 1.
One.
Yeah. But again, we need to practice our raised hands, guys. Yeah, and this has a height of 1. So g of 2 is 1, and 1 is your final answer. That was confusing. Let me do that all one more time. So we started off by saying -3 is the x-coordinate. So -3 is the x-coordinate. I made a giant line here at -3. That's first going into F. So let's figure out where that intersects with F, or that intersects with F at that one spot. What is the height, the y-coordinate of that? 2. Okay, so I grabbed 2. I remember that in my mind. 2 is going to be the new input. 2 is going to be the new x-coordinate. So I draw another line at the x-coordinate 2. Notice that there's 2 points that intersects. Well, that's now going to go into, we've already used up F, we're going to go into G. Where does this line up with G? G is the red line, so I circle that intersection. That has a height of 1. That is our final output. Our output is 1. Okay, let's try one final one to be done with the notes here. Okay, F of G of 0. Someone help me, what do I do? Yeah, Beverly?
Do you go, you start off with the red line, the G line, right?
Okay, this red line,
And you go to 0,
go to 0. On the x coordinate or the y coordinate, 0?
the X coordinate.
Okay, the x coordinate 0, that is right there, okay?
And then it would intersect with -3, right?
So the y coordinate or the output is -3, okay?
Mhm.
So you're saying that G of 0 is -3.
Should I keep going?
It's up to you. If you want to keep going, you can.
And then you would go to -3 on the X coordinate line, and then go up to where it intersects to 2. Right?
Yep. That means that F of -3 is what?
2.
2, yeah. Nice. So our final answer is 2. All right, guys. I know that graphing is the harder one. It is tricky. The best way to get better at these is to practice, and that's what I've given you on Khan Academy. All right, so let's zoom out. So that was all the notes that we took. I will be posting these in a little bit. Give me a fist of 5 on our entire objective. How well can you evaluate composite functions in equations, function or tables, and graphs? Fist of 5, everyone. 4, 5, 4, 5, 3. Open up the chat in case that's happening. Still waiting on Oscar and Chewy. Chewy's at a 3. Oscar's at a 3. Okay, cool. And again, if you need to rewatch this video to help you through the math, there's that. There's the Khan Academy video that's slightly different than mine. But that's all I have for you guys today. So let me go ahead and stop the